In the previous video, we graphed the cotangent function by using a table of values. And remember what we said that the cotangent function has asymptotes at every instance of pi. All right, um, so we would say that the equation of the asymptotes for the cotangent function would be x equals n pi, where n is some sort of integer. And so if we had a different function, then maybe what we could do is use this idea to be able to find, or different cotangent function that is. Then we go through and try to find the asymptotes of that different cotangent function. And so similar to what we did with the tangent function, if I give you the equation, or if I give you the function, we want to make sure that we can find the asymptotes of that function, and then to be able to use the asymptotes to graph the function, just a basic sketch of it, and then also to be able to use technology to graph it. All right, so first thing we're going to do is we're just going to take this 2x and we're going to set that equal to n pi. Okay, so whatever that interior function is, we're just going to set that equal to n pi for the cotangent, and then we would divide both sides by 2, and so the equation of sum of the asymptotes would be x is equal to n pi, where n is an integer. All right, so at this point, we want to try to be able to find the equation of two consecutive asymptotes. And generally what we do is we like to plug in 0 and we like to plug in 1. All right, and that'll give us the equation of two consecutive asymptotes. Now, when n is equal to 0, that gives us x equals 0 times pi divided by 2, or that just gives us x equals 0. Okay, so that's one asymptote. Another asymptote occurs at x equals 1 times pi over 2, or in other words, that x equals pi over 2. And now if we were to graph the function, we know that one asymptote is just going to be the y-axis. Okay, so just imagine that this is one of the asymptotes. And let's just say right here, it's going to be pi halves. Okay, so this would be x equals pi halves. This would be x equals 0. And then if we really wanted to, we can get another one. We would just add 2 pi. So this would be x equals pi. Right? And we know that the cotangent function does this sort of behavior. Right? And so this is what one of the cycles would look like, right? Of this 3 cotangent of 2x approximately. All right. Now, if we were to repeat that behavior because it is periodic, then it would look something like that. All right. So just to get in our mind's eye, we can get a basic overview or a basic idea as to what the function looks like. All right. Now, let's use technology to be able to see what the graph looks like. All right. And so if we were to say y equals 3 cotangent of 2x, all right, there's our function. Let's also plot those asymptotes, x equals 0 and then x equals pi halves. Okay, and there we go. We get a pretty good graph of what we had. Actually, we did a pretty good job of being able to graph this just by hand. Okay, so, but again, we just want to get an idea of what the function looks like. Now, a little bit tougher is when we start increasing the complexity of the interior function. So we have -2 cotangent of 1/3 x plus pi fourths minus 1. Again, we're going to set the interior function equal to n pi. So this is 1/3 x plus pi fourths is equal to n pi. And we're going to solve this for x. So I'm going to subtract pi fourths from both sides. Now notice this has an n, this term, and the pi fourths does not. So they are not like terms. So I'd say this is negative pi over 4 plus n pi. Right? And then finally, we can multiply both sides by 3 to be able to solve. Right? So if I multiply everything through by 3, that means that x is going to be equal to negative pi over 12, or I'm sorry, 3 pi fourths, excuse me, not dividing by 3, but multiplying by 3. That's going to be 3 pi fourths, and then plus 3n pi. All right, so that's the equation of all the asymptotes. Now, if we want two consecutive asymptotes, easy way to do that is to substitute 0 back in and then substitute 1 back in. Okay, so when n equals 0, that just makes this go away. all right, which makes things really nice. Okay, so that's why we use 0 and 1, just because they're easy numbers to work with. Okay? So that would be x equals negative 3 pi over 4 plus 3 times 0 pi, or just x equals 3 pi fourths. Now, when n is equal to 1, that's going to be a little bit trickier, but that's okay. We can handle it. So x is going to be negative 3 pi over 4 plus 3 times 1 pi, or just 3 pi. Now we're going to get a common denominator of 4, so we're going to multiply and divide by 4. So x is going to be negative 3 pi over 4 plus 12 pi over 4. And 12 minus 3, that's ultimately going to give us negative 9 or positive 9 pi fourths. Right? So those are our two asymptotes, okay? And this is, again, this function is going to be pretty far apart between the cycles, all right? So on our graph, one of the asymptotes occurs at negative 3 pi fourths, okay? So this is one of them. And then 9 pi fourths occurs pretty far away, okay? So maybe somewhere over here. So x would be equal to 9 pi fourths. Of course, we can get approximation if we really wanted to, okay, for both of those. Now, look at the function. Remember, it's being reflected, okay? So instead of it going down, okay, so usually our cotangent function does this sort of thing where it goes down, right? So usually it does this, but it's reflected in the x-axis, and also it's shifted down 1 unit. And so if I was to take a guess as to what it would look like, maybe something like this. Okay, I know it's probably not all that good. Okay, um, I'm sorry, other way around. It would go something like this because it's being reflected. Okay, so maybe something like that. Okay, so let's go ahead and let's see what the actual graph looks like. Okay, again, our function is negative 2 cotangents of 1/3. So negative 2 cotangents of 1/3 x, and then we think we have plus pi fourths minus 1. Okay, so plus pi over 4 minus 1. All right, now let's change these asymptotes. Okay, so we had negative 3 pi over 4, right? And then this one we had 9 pi fourths. All right, and if we look at this graph, right, it looks pretty close to what we did by hand. Okay, so we go over here, notice it kind of like this big upward behavior, and then our graphing calculator suggests the same thing. Okay, so again, the whole purpose of this is not to get a really good graph, okay, because we could do that if we really wanted to. We would just make a table of values, but just to be able to sketch something really quickly, okay, just so that way in our minds we can kind of visualize what the properties of the cotangent function might look like. All right, so that takes care of the tangent and cotangent functions. Now, in the next videos, we're going to take a look at our cosecant and secant functions, okay, and that'll be all the graphs of our trigonometric functions.